Hello, this will be a demonstration of proposition 12 from book 3 of Euclid's Elements, which states that if two circles touch one another externally, the straight line joining their centers will pass through the point of tangency. Very similar to the previous proposition, except in this one, the circles touch each other externally as opposed to internally. What that looks like is two circles, ABC and ADE, like that, touching each other at this point A, and it's externally because one is not contained within the other. Call this B, we'll call that C, call that D, we'll call this E, and we'll call, no, that's it. And furthermore, we have the center of circle ABC as point F, and the center of circle ADE as point G. What we've set out to prove is that the straight line FG, which joins their two centers, point F and point G, will pass through the point of tangency, that is point A. For if this is not the case, then FG falls as some other straight line, not through A. We'll say that it falls as the straight line FCDG, and that would look something like that, where that point is C and that point's D. I'm going to write these a little higher if that's the case, like so. Next, we join the straight lines AF and AG. We can do this by proposition, not proposition, postulate 1. I think I called it a proposition in the last video as well. I'm getting lazy. Now, we know that FA is equal to FC by definition 115. They're both radii of the circle ABC. We also know by the same definition that GA is equal to GD, for they're both radii of the same circle ADE. And so if we add these equals to each other by common notion 2, we'll get equals, so that we can say that FA plus AG equals FC plus GD. And by a property of magnitudes, if we add CD to just the one side, namely FC plus GD, it will be greater than the other side. So we can say that FC plus CD plus DG, that is the straight line FG, will be greater than FA plus AG. Now FG, as we have just shown, is greater than FA plus AG, but by proposition 120, which states that if two sides of a triangle be added together, they will be greater than the remaining side. We know that in the triangle AFG, FA plus AG must be greater than FG, so that FG is also less than FA plus AG. So we have arrived at the fact that FG must be simultaneously greater than and less than FA plus AG, which is absurd. And so we can say that FG will not fall as some other straight line, and therefore it will fall through the point A, which is the point of tangency. This being what we have set out to prove, we are done with the proposition, therefore, etc., QED. Again, nothing to say about this proposition, so I will move on to 3.13.